So what I want to take a look at today is the boot up sequence for an EV, what that looks like and the different types of variations that are out there. So what happens in the background when we go into ready mode? So what happens? So everything basically that we're looking at is happening down here in the contactors or relays section of our high voltage battery. So if we take a look here, we can see this is our high voltage battery down here. And these are the relays, again, or contactors that are connecting the battery to the rest of our vehicle. So supplying the high voltage there. So in this section right here, we can see we've got 3 relays that are being controlled. This is our control side, and I've just got the oscilloscope connected up here. So this is our oscilloscope. I've got 1 channel on the high voltage, so we can see how the high voltage builds up, and I've got 3 on the I can see over here for the control of the high voltage plus, high voltage minus, and the pre-charge. There's also a couple of different types of configurations that we can see for that. So right here, we can see here on our contactors on our high voltage battery, we've got here 1 module of 200 volts, positive at the top, negative at the bottom, manual service disconnect in the middle to separate those. And we've got negative and positive here, so in series. So that means that right here, we've got our positive. That would be our positive relay. This is a pre-charge on the positive side. This is our negative relay. If we have a look here at the different types of variations that are out there, there's actually a generation of vehicles that had negative on the pre-charge on the negative side that we can see here as well. And basically, most modern vehicles have no pre-charge resistor, with the pre-charge occurring from the 12-volt battery through the DC-DC converter. So it's a bi-directional DC-DC converter, and it can supply 400 volts from our 12-volt battery. So normally this is the guy that's charging our 12-volt battery, but in the modern vehicles, it goes in both directions and can charge the huge capacitors that are in the inverter there. I'm not going to swap these out today. Perhaps I'll save that for another video where we can see where that is. But basically, we can just swap these out to see what the system would look like in that case. But we're just going to have a look at what the setup sequence is. And we'll have a look at a little bit more advanced version as well. So what we call the smart check, where we can check for the weld, if any contactors have been welded shut. So what I'm going to do is just I'm just going to go into ready mode again. We can see briefly what's going on here. So we can see the sequence of the relays. So as they're switching on and off. So we'll just do that again. Have a look at that sequence. So pre-charge and minus, and then the plus. And I'll go over now and have a look at our oscilloscope. So I've got the oscilloscope set up here as well. So that was just that sequence. I'll let that run one more time. Switch that off, and I'll just press stop so we can have a look at that in a little bit more detail. So having a look at this signal right here. So if we have a look here, this is our high voltage. So we can see here, this is the pre-charge curve that we see going here. So from 0 volts. I've just dropped it down a little bit below because it's at 400 volts and I've got 100 volts per division here. So just so that I get the whole signal onto the screen, I'm just doing it like that. If we have a look here, the next one, I'll just turn them on and off so we can see which one I'm talking about. This one here is obviously then our pre-charge control circuit being switched on, or the contactor being switched on. So we can see here that which one is it? This one? Okay, that's our positive, and that's our negative switching on right here. So we can see right here, negative switches on just briefly before, and then our pre-charge comes on. And as soon as we get those two, we get a closed circuit, of course, and our pre-charge starts for the high voltage system. Once we get to this point where, say, 90% of the voltage is achieved, the BMS says, okay, everything's fine, and now I can turn on the main contactor. So the main contactor comes on here, we get our full voltage coming up to that point right there, so up to 400 volts. The pre-charge can then switch off and say, all right, my job's done. And then we're just left with positive and negative relays closed here until switch off. What you notice there, we've got this tiny little step here. This is when the DC-DC converter switches on and we go from, say, battery voltage of 12.6 volts up to the charge voltage of 14 volts. So that's why we see this little step here. Then at this point right here, we switch off the vehicle. That's where I press stop, and we can see the beginning of passive discharge. So, and I'm at 1 second per division here, so it's less than half a second. And then we've got active discharge where it immediately gets rid of all of the voltage within those capacitors. So that's the basic boot up configuration for an EV. What I'm going to do now is I'm just going to come along here and I'm going to switch it onto smart relays. So smart relays, switch that on here, and we're going to see a slightly different action occurring within the relays. So you can see here now how the relays, so that's now gone into ready mode. There's a different a different configuration on how the relays are working. So again, I'll just do that one more time. So on, off, on, off. And we'll take a look at what that looks like now on the oscilloscope. So, oops, lost the oscilloscope. I have to get that again. So on, off, and I'll just press stop there. So what we can see now is our channel B. I'm colorblind, so not sure what color that is, green, yellow. But we can see how that's been switched on briefly on its own. And what that is doing is we're seeing if the negative relay has been welded shut. Because if we get a buildup of voltage at that point right there, we will know that the negative relay has been welded shut. So at that point, does a very quick pulse. Okay, no voltage is being generated or found on the high voltage DC link, and then it goes to negative relay. So the negative relay switches on briefly on its own. It says, okay, everything's good. And then it switches back on the pre-charge resistor, and then, or the pre-charge contactor. And then we get the normal setup here. So pre-charge phase, switch over to the high voltage. And the difference right here is we've got now, when we switch off, we only switching off that was the positive relay right there. So the negative relay is the one let's just test that. Okay, that's that one there. So the negative relay is all the time on until the end here. So the positive one is only right here. If we switch that off now and we don't see any change in the voltage until we get to this point, then we know the positive relay has been welded shut. And so that's basically a pretty simple way on how modern EVs are able to do a weld check or plausibility check on their contactors. So I hope that's helped. Cheers.